Hello and welcome to episode 6 of Quality Quant Questions. This week we'll be tackling questions based on averages. Ramu appears in 6 different papers in his semester examination, where the maximum marks were 50 for each paper. His marks in these papers are in the proportion 8:9:10:13:14:15. So his marks are 8:9:10:13:14:15. What is the minimum possible additional marks that Ramu should get to obtain 50% of total marks? Here that he got integral marks in each paper. He got integral marks in each paper. His lowest possible score can be 8 plus 9 plus 10 plus 13 plus 14 plus 15. So 42 plus 27, which will be 69. Min score is 69. The next set of integral marks he can score is twice of this, which will still be lower than 50% of the total marks. See, 50 marks for each paper. So total marks is 6 papers. Total marks is 300. So currently he has scored lower than 50%. So he has scored lower than 150. Min score is 68. We can double it. Next possible score is 138. Then all the marks are doubled. And then if we triple it, we will exceed 150. We cannot go that far because he hasn't obtained 50% of the total marks. So in order to get from 138 to 150, which is the 50% of total marks, what is the minimum possible additional marks that Ramu should get? The answer to the question is 150 minus 138, or option C, 12. Next, Ramesh analyzed the monthly salary figures of 5 vice presidents of his company. All salary figures are integers. The mean and median salary figures are 5 lakh. Understand, mean of 5 vice presidents is 5 lakh. So the total is 25. The sum of salaries is 25 lakh. And the mean is 5 lakh. Oh, sorry, median is 5 lakh. If median is 5 lakh, there are two values higher than 5. There are two values lower than 5. Median, as in positionally the middle value. And the only mode is 8 lakh, which means the only repeated value is 8 lakh. 8 will be higher than 5. So 8 and 8 here. This is done. So now in the first two, 8 plus 8 plus 5 is 21. In the first two spots, the numbers have to add up to give us 4. Now, the first two spots, the number have to add up to give us 4, and these have to be distinct numbers. They cannot be identical numbers, because if they are identical numbers, then you would not have the only mode as 8 lakh. So the only way you can split up 4 into two integral numbers is 1 and 3. So finally, which of the options below is the sum in rupees lakh, the highest and the lowest salaries? The sum will be 9. Okay. Next question. Ideally, the wording of the question should be slightly different. All the salary figures are in lakhs and integers. Lakhs and integers. Otherwise, we could very well have the smallest guy having the salary of 50,000, the second smallest guy having a salary of 3.5 lakhs, then 5 lakhs, then 8 lakh, 8 lakh, and then none of the options would fit. So ideally, the instruction should be the salary figures are in lakhs and in integers. Okay. We'll make the edit to the PDF that gets out to people. The average age of the students in an institute was 15 years. Then 10 students of average age 120 joined the institute, and the average age of the students of this institute became 14.8. What was the initial number of students in that institute? Now, there are multiple ways of doing this. One is, let the number of students originally in the institute be n. So 15n plus the sum of ages of the new kids, 120, be equal to this. Now this will be equal to average age of 14.8, the new average, for how many people? Initially there were n people and 10 more have joined. This way we can solve for the value of an initial number of students of that institute. So we get 15n plus 120 is equal to 14.8n plus 148. 0.2n is equal to 28, or n is equal to 140. We can solve it this way. Another way we can solve it is 12 and 15 are giving us an average of 14.8. So this happens. We get 0.2 here as a difference. We get 2.8 as a difference. Now the ratio is 1:14. We know there were 10 people here, so there will be 140 people here. So originally there were 140 people involved. We can get to the answer that way. Another way we can reach our answer, another way in which we can reach our answer is this. See, these 10 people have brought in a deficit of, these 10 people have brought in a deficit of 3 each. The original average was 15. These 10 people have brought in a deficit of 3 each. So this deficit of 30, when divided among the total population, it leads to a drop off in the average of 0.2. This 30, when when this deficit of 30 is divided among the total population, the drop off in the average is of 0.2. So we get 30 is equal to 0.2n plus how much? 2, or 0.2n is equal to 28, or n is equal to 140. Multiple ways of reaching the answer. You could go down this path, you could go down this path, or this path. All the 3 ways are perfectly all right. Regardless of what way you choose, the answer you will reach in every case will always be 140. Or option A is the right answer. Okay. Next question. The average marks obtained by the candidates who passed and those who failed in an examination was 60 and 25. Okay. The average marks obtained by all the candidates who appeared for the examination is more than 43, but not more than 49. Understand, this is critical. This is critical. So the average of all the candidates is more than 43, but not more than 49, means it has to be greater than 43, but less than equal to 49. Average of all. Average of all. The number of candidates who passed is a fraction of total number of candidates who appeared for the examination could never be. Okay. So let's say count of people who passed. Those who passed, X. Those who failed, Y. Or total count of people will be X plus Y. Our overall average will be given. We can make 2 relationships here. The first being 60x. The averages are given for either group. First group has an average of 60, second group has an average of 25. The total average, we can figure out, take the 2 extremes, either 43 or 49. So 60x plus 25y by x plus y is greater than 43, or 17x is greater than 18y. X by y is greater than 18 by 17. But the final ratio we are seeking is not x by y. The final ratio we are seeking is the number of candidates who passed as a fraction of total number of candidates. Total is x plus y. So if we are adding an additional x to the bottom, an additional 18 will come to the bottom, which means this will translate to x by x plus y is greater than 18 by 35. Or the question can now be answered. The number of candidates who passed as a fraction of the total number of candidates who appeared for the examination could never be. It has to be greater than 18 by 35. So this value of 18 by 35 can never be obtained. Now, let's say we went down the other path. Right now, I've made sure it is greater than 43. Let us see if it is less than equal to 49, what would happen? In that case, we would have 60x plus 25y by x plus y is less than equal to 49. Now, 11x has to be less than equal to 24y. X by y has to be less than equal to 24 by 11. Again, we don't want the ratio of x by y. We want the ratio of x by x plus y. So this will translate to x by x plus y is less than equal to 24 by 35. And our entire work is done. Now, see, within this range, 4 by, okay. If I convert every ratio here, if I convert every ratio to the base of 35, it will turn to 21 by 35. This will turn to 20 by 35. This is 18 by 35. This is 24 by 35. 24 by 35 is possible. In fact, every ratio, 19 by 35, 20 by 35, 21 by 35, all the way up until 24 by 35. Each of these ratios are possible. So 20 by 35 is possible, 21 by 35 is possible, 24 by 35 is possible. The only ratio that is impossible is option C, 18 by 35, and that will be our answer. Okay. Next, 10 years ago, the ages of the members of a joint family of 8 people added up to 231 years. 10 years ago. Okay. 3 years later, one member died at the age of 60 years and a child was born during the same. After another 3 years, one more member died, again at 60, and a child was born during the same year. The current average age of this 8-member joint family is nearest to. Now see, the way people get confused in this question is when they try to do everything in the intermediate range. Don't do everything in the intermediate range. Simple work, you can look at it at a macro level and understand. 10 years ago, the ages of the members of a joint family of 8 people added up to 231. So 10 years ago, sum of ages, years ago. So now, if nobody had died, nobody had been born, nothing had happened. After 10 years, for a member for a joint family of 8 people, the ages should rise by 80. It should become 311. They should add 80 to it. But in the interim, what has happened? One 60-year-old fellow has died and one kid has born. One kid has been born. So can I say that has led to a reduction in our sum of 60? And once more, a 60-year-old member has died and a new kid was born. The count of people in the family remains the same, but the sum of ages will come down by 120, which will lead us to 191. The current sum of ages is 191 for a family of 8 members. So the average age turns out to be 23.7875. 23.875. Given that the question asks me, provide the answer to the closest integer. The answer will be 24. This is how you should ideally be doing. But most likely, people will go down this. 10 years ago, the ages was 231. Then what happened? 3 years later, 3 years have passed. So plus 24. One member died at the age of 60 years. So minus 60 and a child was born. After another 3 years, again, sum of ages will go up by 24. Another member died. So minus 60 years. And a child was born during the same year. And then 4 more years will pass. So we'll get to 32. 8-member family, 4 years have passed. So sum of ages will go up by 32. Hopefully you can see the work that is happening, look at the numbers that are getting added. These are the numbers that you are adding. They are identical to 231 plus 80. And the numbers that you are subtracting is as good as subtracting 120. You will still arrive at the same summation, of 191, and you will still arrive at the same number. But doing it piecemeal, doing it when somebody died, when somebody was born, that is unnecessarily burdening yourself with extra work when that can be done in one fell swoop. 80, the sum of ages should rise by 80, and then it will fall by 120 because two people with age 60 died and a new person was born. Okay. The answer to the question is, of course, 24. Next. The average age of 5 members of committee is same as it was 3 years ago because an older member has been replaced by a new member. The difference between the ages of the old and the new member is. Now see, if you understand the language bit of averages, if you understand the language representation of average, it would be so beautiful that you can mark it without writing anything down. The average age of 5 members of a committee is same as it was 3 years ago. Ideally, the average should have risen by 3 because 3 years have passed, so the average age should have risen by 3. So sum of ages should have risen by 15. But because the average remains the same, the sum of ages has not risen by 15. If sum of ages has not risen by 15, how can that be? Because an old member has been replaced by a new member. So what is the difference between the age of the old member and the new member? It is 15 years. This is all the language input that is needed. But if you want to do it algebraically, let's go. Let the average age of the original group be A. So 5A plus 15 minus the old member going away. Let the old member's age be N. Old member's age be old member's age is Y, new member's age is X, minus X plus Y, whole thing divided by 5 is equal to A again. So from here we get 5A plus 15 minus X plus Y is equal to 5A. These two cancel off. We take minus X and plus Y to the other side. So X minus Y is equal to 15. But formulating this algebraic expression, formulating this entire thing is unnecessary. The age should have risen by 15. It has not risen by 15 because the new member has brought in 15 years less than the old member. The difference between the ages of the old and the new member is 15 years. Directly, we can reach that conclusion. Next. The class teachers of 3 classes, X, Y, and Z, give an algebra test to their respective students. The average scores in class X, Y, and Z are 83, 76, and 85 respectively. The average score of all the students in classes X and Y together is 79. And the average score of all the students in classes Y and Z together is 81. What is the average for all the 3 classes? Now, this is a question that I know has come in CAT. This is a question that has also come in SNAP. I think SNAP 2021 came in, but regardless, let's do the working. Now, there are 2 ways of doing this. One, you can use allegation. The other, you can use equations. I, for one, like allegation. So first, I'll do it by allegation for class X and class Y. We have 83. We have 76. These 2 classes average out to give us 79, which means a difference of 4, a difference of 3. The ratio of students in X and Y is 3:4. Then we have average of Y and Z. So Y has 76, Z has 85, and they average out to give us 81. So ratio of students in Y and Z is 4:5. Now if I want average of all the 3 classes together, I can happily assume X has 3 students, Y has 4 students, and Z has 5 students because the ratio of students is 3:4:5. Now, even after this stage, there are 2 ways you can go about doing it. One is the absolute maths, 83 into 3 plus 76 into 4 plus 85 into 5 divided by 12. 3 plus 4 plus 5. So we'll get 249 plus 16, that's 224. 80 into 4 is 320, so 304. Let me see, 70 into 4, yes, 304 plus 85 into 5, which will be 425 divided by 12. So 49 plus 29. 49 plus 29 will be 68. And 968 divided by 12. 5498, 1 carried over 7. 49 and 29 will be 70. 978 by 12. Can cancel it off by 6 first. This gives me 2. This gives me 1. 37, 6, 18, 3. You can cancel it off further to get you to 81.5. Answer is 81.5. That is guaranteed. But instead of doing the multiplication of these humongous numbers, what we could have done, and a very useful tool at the time of calculating averages, is doing assumed mean. See, if assumed mean, if I take my assumed mean to be 80, my average would be 80 plus class X has 3 extra for 3 people. So 3 into 3. Class Y has 4 deficit for 4 people, minus 4 into 4. And class Z has 5 extra for 5 people, plus 5 into 5. Whole thing divided by 12. So I get 80 plus 25 plus 9, 34, 34 minus 16, 18 by 12, which will again be equal to 81.5. The same number of 81.5 can be arrived at using assumed mean. And it is far more convenient to do the calculations here instead of multiplying the larger numbers. Okay. Now this is when we are using allegations per se. A lot of people don't like assumed. The default thought is not allegations. The default thought is let us make equations. So let the students in XBA, count the students in XBA, count the students in YBB, and count the students in ZBC. So 83A plus 76B is equal to 79A plus 79B. Equation like this. 83A plus 76B is 79 times A plus B, which gives us 4A is equal to 3B, or A by B turns out to be 3 by 4. See, the ratio of students in X and Y is 3 by 4. Same thing, 76B plus 85C is equal to 81B plus 81C, or 4C is equal to 5B, or C by B is equal to 5 by 4. Now that we have A is to B is to C, as 3 is to 4 is to 5, then we engage in the same process in order to calculate average. 83 into 3, 76 into 4, 85 into 5 divided by 12, or use assumed mean. In either case, the answer will turn out to be option B only. I don't like this. I like the allegation-based idea, because for allegation-based idea, honestly, it takes very little writing, and I am far more confident of my answer. I am more prone to making errors when I make equations like this. So whatever floats your boat. Let's go. Next question. A shipping clerk has 5 boxes of different but unknown weights, each weighing less than 100 kg. The clerk weighs the boxes in pairs. The weights obtained are 110, 112, 113, 114, 15, 16, 17, 18, 20, and 21. What is the weight of the heaviest box? Now, I hope this iteration of question you have either come across in DILR or in quant. This is a very, very popular setup. Right now, 2 boxes are being paired at a time. There could also be an instance of 3 boxes being paired at a time. There are very wonderful, there is a very wonderful way of solving this. Once you know that way, this question is easy. Until the time you know that way, it may appear to be a little tough. First thing we do is we list down all the weights that we have. Sorry. 18, 16, 17, 18, 120, and 121. Now, even for finding sum here, what I prefer doing is, I see 110 is present in every term. So I do 2, 110 is present. So 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. Sum of first 8 natural numbers is 36. 1 gone from that. So 35. 35 plus 21, 56. So 110 into 10 is 1100. 110 into 10 is 1100 plus 56. So summation is 1156. Assumed mean has wonderful applications. Instead of doing 2 plus 3 plus 4, you could do it that way, but it is far more cumbersome and the likelihood of you missing out on some carry or making some error is high. Now this summation is 1156. Now understand how this 1156 has come into being. Let's say the 5 kids were labeled A, B, C, D, and E. A is the lightest kid or lightest box. B is the second lightest box. C is the third lightest box. D is the fourth lightest box. And E is the fifth lightest box. Now, A would have gone up on the weighing scale, wherever the weighing is happening. How many times? A would have gone up on the scale once with B, once with C, once with D, and once with E. Similarly, how many times B would have gone up on the scale? Once with A, which is already recorded, then with C, then with D, and then with E. And how many times C would have gone up? Once with A, once with B, once with D, once with E. And D would have gone up on the scale also 4 times. Once you have one box identified, the other box that you can pair it up with, it can happen in 4 ways. So, how many recordings do we have here? How many recordings do we have here? We have 10 recordings, which is equivalent to the 10 numbers, which is great. And how many times each box has gone up on the scale? You can count it. If A is identified, the pairing that it has can be identified in 4 ways. Another way you can look at it is, for each of these 10 weighings, there are 2 boxes on the scale. So overall, how many boxes have gone up on the weighing scale? 20 boxes, because there are 10 recordings. 20 boxes have gone up on the scale. Now that 20 boxes have gone up on the scale, every box is as special as the other. Each box would have gone up on the scale identical number of times. There are 5 boxes. There are 20 boxes that have gone up on scale. So every box would have gone up 4 times, 20 by 5, 4 times. Regardless of how you reach it, regardless of how you reach that conclusion, can you see this 1156 is each of the boxes going up on the scale 4 times? So 4 times of A plus B plus C plus D plus E is 1156, or A plus B plus C plus D plus E is equal to, you divide this by 4, 1200 minus 11, 289. This is 289. The sum of weights of the 5 boxes is 289. Now, the other interesting part is, look at this smallest number, 110. Which 2 boxes will create the lowest weight? Of course, the 2 lightest boxes. So 110 is A plus B. This is 110. Now look at the other extreme. Which 2 boxes will make the heaviest weight? Of course, the 2 heaviest boxes, D plus E. So D plus E is 121. And at this time, At this time, you would be able to identify the weight of the third lightest box. C will therefore be, this is 110, this is 121. C will therefore be 58 kg. We know the third lightest box weighs 58 kg. Okay. Now up until here, lot of people reach. Even after this, there is one additional bit. Look at this 112. Look at this 112. How would this 112 be created? It 100 AB is used up with 110. DE is used up with 121. Can 112 be created by AD? No, there is a weight lighter than AD. A plus C. A plus C is lighter than AD. This is the second lightest weight. 112 is the second lightest weight. How can AC be created? Can it be done with AD? No, there is AC lighter than that. Can it be done with AE? No, AC is lighter than. Can it be done with BC? No, AC is still lighter than that. C and C is identical. A is lighter than B. Can it be done with BD? No, A is lighter than B. B is lighter than, sorry, C is lighter than D and A is lighter than B. So AC will be lighter. Can it be done with B? A is lighter than B. C is lighter than E. With CD, CC is identical. A is lighter than D. Can it be done with C? CC is identical. A is lighter than. This has to be the second lightest grouping. This has to be the second lightest grouping. A plus C has to be the second lightest grouping. The wonderful thing here is we already know value of C. We know value of C is 58, which would now enable us to get, if C is 58, then A will have to be 112 minus 58, or A is 54. A is 54. Now A plus B I know to be 110. If A is 54, B will be 56. The first three weights are uniquely identified. I'm deliberately taking the longest path to the answer so that everything that you can possibly infer here can be identified. Now, the next part. See, this weight of 120, the second heaviest grouping. How can the second heaviest grouping be made? It can only be made by CE. CD will be lighter than CE because D is lighter than E. BE will be lighter than C because B is lighter than E. BD will be lighter than C because B is lighter than C, D is lighter than E. BC will be lighter than C because C and C is identical, B is lighter than E. AE, C is heavier than A. CE and versus AD, A is lighter, D is lighter than C and E respectively. Then CE has to be the second heaviest weight, second heaviest grouping. C is the second heaviest grouping. C plus E is 120. Again, we know the value of C already. It is 58. So E has to be 62. E has to be 62. And D plus E is 121. D plus E is 121. If E is 62, D has to be 59. We are able to arrive at precise weights of all five groupings. We are able to arrive at precise weights of all five groupings. Now, if we wanted to identify 113, what grouping is this? Now that we have numbers, can you see 113 is B plus 59 plus 54? It is A plus D. It is A plus D. But let's say if we are not looking at numbers and we are simply looking at pairs as identified here. We are simply looking at pairs as identified in our list here. Now the third lightest grouping. Can it be AD or can it be BC? You can't be certain because A is lighter than B, but C is also lighter than D. So which of these two groups makes 130? That cannot be ascertained with absolute confidence. Similarly, look at 180. Is it created of CD or is it created of BE? C is heavier than B, but E is heavier than D. You cannot be absolutely certain which grouping has made 118. Cannot be absolutely certain which grouping has made 118 because we don't know whether the margin by which C is lighter than D or the margin by which D is lighter than E, which is larger. If you now that we have numbers, we can uniquely identify, but in the absence of numbers, the identification of which groupings are making the numbers can only be done for the four extreme values, the two right at the extremes and the two next to them. For the middle ones, we will always be unsure. For this particular case, if we wanted to list it out, it will be A plus D here. Then 114 will be B plus C. Then 115 will be B plus D. Then 116 will be A plus E. Then 117 will be C plus D. And finally, E plus E. 118 will be D plus E. With presence of numbers, we can make comments about these middle ones. In the absence of numbers, with only the variables assigned to them, we can only say the first grouping has to be the two smallest, the second grouping has to be the smallest and the third smallest, the largest and the second largest, the third largest and the largest. We can only be certain of the four extremes. Hopefully a lot of insight, which was not really needed for this entire question. For this entire question, the work was very limited, but we have learned something here. What is the weight of the heaviest box? The weight of the heaviest box is option C, 62 kg. Next, the average cost per fruit of 5 apples and 4 mangoes is 48. And the average cost per fruit of 7 apples and 8 mangoes is 60. Find the total cost of 24 apples and 24 mangoes. This is a beautiful question because look at what is given to us. 5 apples and 7 apples, 4 mangoes and 8 mangoes. So 5 apples and 4 mangoes. Average cost per fruit, 5 apples and 4 mangoes. When I write it as 5 apples plus 4 mangoes should be equal to 48 into 9 or 432. An average cost of 7 apples and 8 mangoes. 7 apples and 8 mangoes should be 15 into 6. 15 into 6, which is 900. Or we've got cost of 12 apples and 12 mangoes as 1332. Finally, they've asked me the cost of 24 apples and 24 mangoes. We simply have to double this up. So you get 24 apples and 24 mangoes as 2664, or option C is the right answer. Yeah. Next one. The average of the ages of a man and his only son exceeds the average of the ages of his wife and his son by 25%. The age of his son is 30 years less than the age of his wife, whose age is 10 years less than his age. Okay. So how we break this down is, let us take the age of the man as X. Therefore, the wife will be X minus 10. And finally, the age of the son is 30 years less than the age of his wife. X minus 40. The ages in terms of ages of man will be these. Now, equation-wise, the average of the ages of man and his only son. So, X plus X minus 40. This is the sum of their ages. So, average would be, when I divide it by 2, there were 2 people. Exceeds the average age of his wife and his son. Average age of his wife and his son will be X minus 10 plus X minus 40 by 2. This is the average age of the wife and the son. But we are told the average of the man or son's age exceeds the average of wife and son's age by 25%, or this is 1/4. This is 1/4 more than this, or I can write it in equation form directly as 5 by 4. Now we have to solve for X from here. 2 and 2. 2X minus 40 is equal to 10x minus 250 minus 10 minus 40. 10x minus 250 divided by 4. We bring it over here. We get 8x minus 160 is equal to 10x minus 250, or 2x is equal to 90, or x is equal to 45. Now, one very silly error that people tend to do. Very silly error that people tend to do. We've got x equal to 45, so answer to the question will be 45. Please don't do that. Whenever you think you've arrived at an answer, please devote some extra 5 seconds to read the final question. Final question is, find the age of his son in years. This 45 that we've got is the value of x, and value of x was the age of the man. The man is 45, the wife will be 35, the son will be 5. The answer is not 45 despite it being the variable that you have solved for. The answer is only 5. Please, please, please don't make an error like this, because this is the saddest error. You have spent your time in solving it correctly. You have got into the right setup. You have got into the final right working that you should be doing. But eventually, what you've done is you marked the wrong thing as the answer. Please don't do that. This is very, very common in solving, especially when it comes to data questions. Please, let's not make this error. Next question now. There are 9 3-digit numbers with distinct units digits. Each number is reversed, and the reversed number is subtracted from the original number. Okay? Each number is reversed, and the reversed number is subtracted from the original. The results were found to have an average of 0. If for each number, the hundreds digit is not less than its units digit. If for each number, the hundreds digit is not less than its units digit, find the average of the hundreds digit of the greatest and the least numbers. Okay. So this is a question which is very, very fun. At the same time, it is very, very easy. If you understand the language of the question, this will be very, very easy. See, there are 9 3-digit numbers with distinct unit digits. You don't have to write everything now, but for explanation purposes, I will have 1, 2, 4, 5, 6, 7, 8, and 9. You would also have a number ending with 0, not a problem. Also have a number ending with 0, I don't care. Now see, each number is reversed. Each number is reversed. So this becomes 1 something something. This becomes 2 something something. This becomes 3 something something. This becomes 4 something something. This becomes 5 something something. This becomes 6 something something. This becomes 7 something something. This becomes 8 something something. This becomes 9 something something. Each number is reversed, and the reversed number is subtracted from the original number. So A, B, C, D, E, F, G, H, I. A, B, C, D, E, F, G, H, I. We're doing A something 1 minus 1 something A. I just want you to see. I will do it for the first one, and then for the subsequent ones, let's say the digit here was X. The value of the first number is 100A plus 10X plus 1. And value of the second number is 100 plus 10X plus A. If we subtract the bottom number, the reversed number from the original one, we'll get 99 times of A minus 1. 99 times of A minus 1. Here we'll get 99 times of B minus 2. Here we will get 99 times C minus 3. 99 times of B minus 4. 99 times of E minus 5. Then 99 times of F minus 6. 99 times of G minus 7. 99 times of H minus 8. And 99 times of I minus 9. These would be the results that you get when you subtract the reversed number. The results were found to have an average of 0. How can these numbers have an average of 0? These numbers can have an average of 0 if each of them are 0. The results of these, the average of these numbers can be 0 if each of the numbers are 0, or some of them are positive, some of them are negative. Essentially, everything cancels each other out. Okay. Then we have, if for each number, the hundredths digit is not less than its units digit. So, A is not less than 1. I is not less than 9. If I is not less than 9, can I state with absolute confidence, this has to be 9? This has to be 9. Now, H is not less than 8. H is not less than 8. So it can be 8 or it can be 9. If I take it as 9, see, this is giving me 0. Now 99 times of I minus 9 is giving me 0. This is guaranteed. If I take H as 9, this will give me a positive result. Pay attention. The only way we could have gotten average as 0 here was if each of these values turned out to be 0, or if some of them were positive, some of them were negative. With this instruction, if for each number the hundredths digit is not less than the unit digit, can you see none of these expressions can be negative now? A minus 1 will be 0 or positive. B minus 2 now will be 0 or positive. C minus 3 now will be 0 or positive. D minus 4 now will be 0 or positive. The only way we can get average as 0 is if each of the variables that we have, I turns out to be 9. I turns out to be 9, H turns out to be 8, G turns out to be 7, F turns out to be 6, E turns out to be 5, D turns out to be 4, C turns out to be 3, B turns out to be 2, and A turns out to be 1. The only way we can do that is if each of these terms turn out to be 0, only then will their average be 0. Okay. Now that we also have this, find the average of the hundredths digit of the greatest and the least numbers. Average of the hundredths digit of the greatest and the least number. 1 plus 9, the average of these two numbers is 5. While I've taken a lot of time in explaining every nook and cranny of this question, understand, if we had worked our way backward, we wanted a number, we reverse it, and we get the average as 0. The best way to accomplish it is taking 3 repeated digits. If I took my numbers as 1, 1, 1, even when I reverse it, the difference will be 0. If I take 2, 2, 2, again 0, again 0, again 0, again 0. All the conditions would be satisfied if I had taken 3 repeated digits. If all the conditions are satisfied, if I had taken 3 repeated digits, and all the options are also precise, then regardless of whether this is the only case or is not the only case, the answer I get here will be valid everywhere. Therefore, the numbers that I'm dealing with are simply these. You don't really have to list them down. In your head, you can see 111 and 999 will be the smallest and the largest number. And the average of the hundredths digit of the greatest and the smallest number is going to be 5. You could have marked your answer this way in your thought itself without having to necessarily do all this processing. Hopefully the processing helped for somebody who had trouble with this question, but this processing was not really needed in order to arrive at the answer here. Okay. Next question. Arjun ate a number of chocolates on each of the 5 days of a certain week. On Tuesday, he ate 2 more than on Monday and 8 less than on Wednesday. On Friday, he ate 4 more than on Thursday and 6 less than on Wednesday. The average number of chocolates he ate on the first 3 days and the last 2 days are in the ratio 4:3. Find the number of chocolates he ate on Thursday. Okay. So we write it down: Monday, Tuesday, Friday. On Tuesday, he had 2 more than on Monday. So if this is x plus 2. On Tuesday, he ate 2 more than on Monday and 8 less than on Wednesday. So Wednesday, he ate 8 plus 10. On Friday, he ate 4 more than on Thursday and 6 less than on Wednesday. So this is x plus 4. Thursday, he ate 4 more than. On Friday, he ate 4 more than Wednesday. So this is known. Now the sum of chocolates eaten on the first 3 days is 3x plus 12. Sum of chocolates eaten on the last 2 days, Thursday and Fridays, 2x plus 4. So the average here is x plus 4. The average here is x plus 2. We're told x plus 4, x plus 2 equal to 4 by 3. So we get 3x plus 12 is equal to 4x plus 8, or x is equal to 4. Finally, they've asked me find the number of chocolates he ate on Thursday. Thursday he ate 4 chocolates. So the answer to the question is option B. Next question now. The members of a club meet for lunch every day. Last week, just before the bill was presented, 6 of the members were called for an official meeting and hence they left. The remaining members were presented with a bill of 2160. It was customary to divide the bill equally. To cover the share of those who left, each member had to pay 81. How many members met for lunch? Let the number of members, overall number of members, be n, and their share of bill, if nobody had left, be a. So you would have n into a is equal to 2160. Additionally, 6 members have left now. So you'll have n minus 6, and as a result, everybody has had to pay 81 more than the average. This is equal to 2160 again. The total bill will remain the same. Now, if I open up the second expression, I'll get NA minus 6A plus 81N minus 486 is equal to 2160, or 81N minus 6A is equal to 86. So 262646. I can divide everything by 3. So I get 27N minus 2A is equal to 27N minus 2A is equal to 882. Now we can get value of A from here as how many members met for lunch. We want to find out N, so I should be replacing A. A is equal to 2160. Then let us replace that here. We get 27N minus 2 into 2160 by N is equal to 882. I can cancel off 27 from everywhere. So this will go away. This divided by 27 will give me 381. Can't cancel 27 from. This is not divisible by 27. This will be divisible by 9. So 3n. This divisible by 9 will give me 88 and 9. 72, 8. This by 9. 240. Okay. So I get 3n square minus 98n minus 480 is equal to 0. Now 3 into 480 is the product of roots. Sum of roots is, we have to break down 98 into two numbers. That give me 3 into 480. Oh, this is fine. Seems like it at this time. So I break this down. Hope I haven't made a mistake anyway. 327 and minus 2a is 882. I need up to be 3 into 480, which is 1440, and the difference has to be 90. Difference has to be 90. So 6 into 240 works. 12 into 20 works. 12 into 120 gets me to 108. So 16 into 90. Difference here is significantly lower. So I can't have that. Then 8 into 180. 8 into 180. No. They're doing from 10 into, okay. Eighteen into 80 everything. But this is adding up to 98. As I want the difference to be 98. I made a mistake somewhere. Let me check. 1 in minus 6 there. Minus 486. Yes. Minus 486 comes to this side. 2646. Yes. 27 and minus 2a is equal to 882. 882. This is fine. From here, 27n minus 2 into 2160 by so fine is equal to 882. It's also fine. 882. Yes. Seems like it. 9. 8. Also fine. 3n square minus 98n minus 480. How do I break this down? This breakage is becoming very problematic. And given that it is becoming problematic, I will start my work all over again. Let the number of members meeting for lunch be n, and their bill contribution is NA or A. Every person is giving A. So NA is 2160. Because 6 members left, n minus 6 into A plus 81 will now be equal to 2160. So NA, I hadn't removed NA. That is my point. So NA minus 6A plus 81n, I know where the error happened, minus 486 is equal to 2160. I know NA is 2160, so this NA and this 2160 will go for a toss. We'll be left with 81n minus 6a is equal to 486. I can divide it by 3, so you get 27n minus 2a is equal to 162. This is fine. Now from here, a will be equal to 2160 by n. Replace it in the equation. 27n minus 2a sorry, minus 2 into 2160 by A is equal to 162. Now I can cancel off 27s. This cancelled by 27. This cancelled by 27. This means 80 here. This means 6 here. This is not A, this is N. So I get N square minus 6N minus 160 is equal to 0. This is easy to do. This is N square minus 16N plus 10N minus 160 is equal to 0. N times of N minus 16 plus 10 times of N minus 16 is equal to 0. So N is equal to 16 or minus 10. Clearly, the number of members cannot be negative. So answer to the question has to be option A. I missed out on cancelling out NA and 2160 in the last iteration, which led me to the wrong spot. Okay. Next question. There are n students in a class. The class teacher gave them a task of finding the average of the first n natural numbers, and each of them left out a different number, found the average of the remaining numbers. The average of the averages obtained by all the students was 21. Find n. This is such a straightforward question. Perhaps you can see it for a smaller set of numbers. Let's say there were only 4 kids in class. Let's say there were only 5 kids in class. 5 kids. It will be easier to see. If there are 5 kids in the class, the first kid leaves out 5. So he gets 1 plus 2 plus 3 plus 4. He gets a summation of 10. Sum of 10 or average of 2.5. Let the next kid miss out on 4. So we'll have 1 plus 2 plus 3 plus 5 or summation of 11 or an average of 2.75. Let the next kid miss out on 3. So 1 plus 2 plus 4 plus 5. Summation will turn to 12 or an average of 3. Next kid miss out on 2. So 1 plus 3 plus 4 plus 5, which is equal to 13, average of 3.25. And the final kid will miss out on 1. So we'll have 2 plus 3 plus 4 plus 5, summation of 14 or an average of 3.5. Now the average of averages turns out to be 3 itself, which is equivalent to the average of the numbers that we had. 1, 2, 3, 4, 5, average of the numbers that we had. So if everyone is missing out on precisely one number, and each of those numbers are different numbers, the average that you get of all the averages is identical to the average that you would get for the list of first n natural numbers. So if you are told the average of the averages obtained by all the students was 21, 21 is the average of all the numbers, or as in average of all the natural numbers that were there. Now this 3 can be obtained by 1 plus n by 2, whatever first natural numbers. 1 plus n by 2 is equal to 21, or n will be equal to 42 minus 1, which is equal to 41. Therefore, the answer should be C. This is one way of doing it, observational logic. The other way of doing it, if you are more inclined towards the algebra working of it, let's say sum of first n natural numbers is given by n into n plus 1 by 2. Now every kid has missed out on a different number. So let's say the first kid missed out on 1. The second kid missed out on 2. The third kid missed out on 3. So on and so forth, it will keep on going until the last kid missed out on n. Now average for this expression, or let's say how many expressions are these? If I want to find out average everywhere, I have to divide each of these numbers by n minus 1. These are the summations These are the summations. The averages would be first thing n into n plus 1 by 2 minus 1 whole thing divided by n minus 1. This would be the average. For the second kid, the average would be n into n plus 1, 2, 2 whole thing divided by n minus 1, like this. Okay, and it will keep on going. Will keep on going until the last kid, n into n plus 1, 2 minus n whole thing divided by n minus 1. These would be the averages obtained by every individual kid. This would be the average obtained by every individual kid. Now, if we want average of averages, these will need to get added up. These will need to get added up. Like erasing this part, left hand side part, so we don't need it anymore. If we need average of averages, these would need to be added up, and their summation will be very nice. It will be simply n into n plus 1 minus 1 plus n into n plus 1 minus 2, so on and so forth, up until n into n plus 1 minus n whole thing divided by n minus 1, because everywhere the denominator is the same. Now this is the sum of all the averages. If I want average, I need to divide this expression. By n. I can either write it this way by n, or given that this n is in the denominator only, I can write it here, is present here. Okay. And this is told to us as equal to 21. This is told to us as equal to 20. Now look at one wonderful thing. How many times does this n into n plus 1 gets added? It gets added n times. See how many terms are there? 1, 2, 3, 4, 5, 6, 7. N times. There are n terms. So n into n plus 1 gets added n times, or their summation is n square into n plus 1. And finally, what do we, for these portions, the negative portions, minus 1, minus 2, minus 3, minus 4, minus n, they will add up to give us n into n plus 1 whole thing divided by 2. This entire thing has to be divided by n minus 1 into n. In order to bring this 2 down to the bottom, I will multiply 2 here and bring this 2 down to the bottom. This is equal to 21. Now see the wonderful things that we can eliminate. We can remove n from every term. Now the equation will simplify. I will take it over here. I will take this denominator over here. 42 times of n minus 1. LHS, we will have 2n square plus 2n minus n minus 1 is equal to 42n minus 42. 2n square plus 2n minus n minus 1 minus 42n minus 42. Can bring everything over to the other side. We'll have 2n square plus n minus 41n minus 41n plus 41 is equal to 0. There has to be some mistake that we have done along the way. There has to be some mistake, because it should be n square minus 40n. Up until this last step, I am fairly confident the working is accurate. Until this point, I am fairly confident the working is accurate. N into n plus 1, n times. So it will be n square n plus 1 minus n into n plus 1 by 2, 1, 2, all the way up until n. Whole thing divided by n minus 1 into n. This is equal to 21. Okay. You can bring this 2 down. This 2 will also go here. Now n can be cancelled from each term. So I open it up, I get 2n square plus 2n minus n minus 1 is equal to 42n minus 42. Okay. So let's see. 2n n plus 1 n plus 1. Okay. Bring it over, I get 2n square minus 41n plus 41 is equal to 0. 2 into 41 has to be broken down. Two numbers that give me a summation of 41. There is no way that can be done. This has become so much more troubling than it should have been. Hopefully the observational logic part was clear, because I will try this writing all over again. Once I get stuck, I try the writing again. So the first kid, let's say his observation, first kid, he will get sum of first n natural numbers, n into n plus 1 by 2 minus 1. Second kid, n into n plus 1 by 2 minus 2. And the nth kid, summations. These are the summations. You'll get n into n plus 1 by 2 minus n. These are the summations that they're getting. The averages that they will get is, I'll simplify this, n into n plus 1 minus 2 by 2 whole thing by n minus 1. For the second kid, the average would be n into n plus 1 minus 4 by 2 by n minus 1. And for the last kid, n into n plus 1 minus 2n by 2 by n minus 1. These are the individual averages obtained by the kids. Now the summation of this would be n into n plus 1 minus 2 by 2 times of n minus 1. This is for the first kid. This is the average of the first kid. Average for the second kid. See, this 2 I have brought down here will be n into n plus 1 minus 4 by 2 times of n minus 1. So on and so forth. It will continue going up until the last kid will have n into n plus 1 minus 2n by 2 times of n minus 1. This is the sum of averages of all the kids. This is the sum of averages of all the kids. This is the sum of averages of all the kids. Average of them would be this entire expression divided by n. This entire expression divided by n. Okay. This entire expression divided by n. Now see, I'm working only with the numerator. Denominator is identical everywhere. Denominator is identical everywhere. So I can simplify this to bring all that denominator down with n. N into 2 into n minus 1. This will be equal to 21. N into 2 into n minus 1 is equal to 21. For the numerator, I've got n into n plus 1 once, twice. How many times will I get it? I will get it n times. So I will get n square n plus 1. And then these negative parts. Minus 2, minus 4, minus 6, minus 8, minus 10, so on and so forth, up until minus 2. That is as good as sum of first n natural numbers. Sum of first n natural numbers multiplied by 2. So that would be equal to minus n into n plus 1. Okay, this expression seems more likely to give me a favorable result. So n and n will get cancelled. This n will get cancelled. This gets over here. Now left with, I'll have to erase this portion here. Let's this. So I now have n square plus n minus n minus 1 is equal to 42n minus 42. This is gone. This is gone. We bring our stuff to the other side. I have n square minus 42n plus 41 is equal to 0. Finally, so I'll have n minus 1 to n minus 41. N minus 1 into n minus 41 is equal to 0. So n is equal to 1 or it is equal to 41. Among the available options, of course, C will be marked. And 1 cannot be the number, because if n was 1, the first kid missed it by 1. There was just one number, there was just one kid, and he missed one number, his average would be 0. The average of averages obtained will never be 21. So this is of course wrong. This way we will reach 40. This is the algebraic way. Hopefully you realized algebraic way is not something I'm very fond of or comfortable with, because this is unnecessary work when it can be done by simple observational logic. See, average of averages should ideally have given me. If no kid has made an error, the average of average would be average of all the numbers. Given that every kid has missed out on a different number, the average of the numbers missed out would also be equal to average of averages only. Therefore, the 21 obtained here is the average of all the natural numbers involved. You can directly get to 41. Okay. So glad it is over. Next question. Let's see. The students of 3 classes A, B, C take a test. The average per student marks of classes A and B put together is 17. The average marks per student of classes B and C put together is 76. The average per student marks of class A and C put together is 79. Find the range of average marks T of all the 3 classes put together. Okay, that's it. Let class A have A kids, class B have B kids, and class C have C kids. And their averages are X, Y, and Z. So when we are told average per student marks of classes A and B put together is 71, we are told AX plus BY is equal to, this is number of kids, this is average per class, 71 X plus 71 Y. Sorry, not 71 X plus 71 Y, is 71 A plus 71 B. Sum of marks of class A plus sum of marks of class B is equal to 71 times the number of kids that they have. Similarly, for class B and C put together, it will be BY plus CZ is equal to 76 times of B plus 76 times of C. And finally, for A and C put together, we have AX plus CZ is equal to 79A plus 79C. Now, let us add up both the sides. We'll have 2 times of AX plus BY plus CZ is equal to 150A plus 147B plus 155C, or AX plus BY plus CZ has to be to 75A plus 73.5B plus 77.5C. Now, notice, finally we need range of average marks of P of all the 3 classes put together. Average marks would be A plus B plus C. You have to divide this left hand side also and right hand side also, A plus B plus C. Now, if we are trying to divide the right hand side, just notice the right hand side. Can I say the 75A by A, 75A by A only? 75A by A only. Can you see? It will be 75. 73.5B by B only. It will be 73.5. 77.5 C by C. Now, the average has to lie within the largest and the lowest value. In any data set, the average has to lie between the largest and the lowest value. Left hand side, we don't need to do any editing. This is the final value. This is essentially equal to P. This entire expression is equal to P. You see here, I can break this down as 73.5A. This is the coefficients that I have, plus 73.5B plus 73.5C plus 1.5A plus 4C, whole thing divided by A plus B plus C, which I can further write as 73.5 plus something. This processing or this working is done. This is the coefficient I have for B. Can you see my average? My average for all the 3 classes put together has to be greater than 73.5. Has to be greater than 73.5. And just basis this, I can mark my option D as the answer. Just basis this, I can mark my option D as the answer. But we'll also go ahead and see how it is less than 77.5. Now I can write it down as, now I will write every term down as 77.5A plus 77.5B plus 77.5C minus 2.5A minus 4B by A plus B plus C. If I divide this or simplify this further, I'll get 77.5 minus 2.5A minus 4B by A plus B plus C, or this should ensure it will be 77.5 minus something. So my average can never manage to reach 77.5, and my average will always exceed 73.5. We can reach that result by processing, and therefore the answer to this question has to be option D. Okay. Next question now. The students of 3 classes XYZ wrote a test. The average marks of the students XYZ are 70, 81, and 90 respectively. The average marks of the student of X and Y is 76. Average marks of students of Y and Z is 86. Find the average marks of the students of all the three classes to the nearest integer. Okay. We do. This is very similar to an earlier question. We have 70 and 81. We reach the average of 76. So this is 5. This is 6. X and Y have student population in the ratio 5:6. Then we have Y and Z. Averages are 81 and 90. And the final average we reach is 86. So this is 4. This is 5. So ratio students of Y and Z is 4:5. So X is to Y is 5:6. Y is to Z is 4:5. So if you want to make it proper, 12, 6 and 4, LCM is 12. This has become 3 times, so this will be 15. This has become twice, so this will become 10. The ratio of students in X, Y, and Z is 10:12:15. Now, find the average marks of all the students in the three classes to the nearest integer. We can use the assumed mean. Hopefully, we will use the assumed mean. For section X, we have, I'm taking the assumed mean as 80. So minus 10 into 10 plus minus 10 into 10 plus 12 into 1 plus 15 into 10 whole thing divided by 10 plus 12 plus 15, which is 37, which is 37. So 100, and this one's to give me 50. 50 by 12 is 62. So 80 plus 62 by 37 I'm reaching. Now 62 by 37 is more than 1.5. 1.5 would be around 55. This is more than 1.5. So given that we have to reach our answer to the nearest integer, the answer would be 82. To the nearest integer, the answer would be 82, which will be the final answer here. For this question, in a class there are 50 students. The average weight of all the girls is 30 kg. The average weight of any of the 30 of the boys is 40 kg. Which of the following can be a possible value of the average weight of the entire class in kg? Now understand what this line means. We have not been told how many boys are there. Not been told how many boys are there. We have been told if you take the average weight of any 30 boys, the average weight is 40 kg. Which is another way. And one way to accomplish this is let the weight of each boy be 40 kg. So there are two extreme situations possible. One, when the boys are exactly 30, girls are 20, because there are 50 students in total. Sum of weights of boys will be 40 into 30 or 1200 in this case. Sum of weights of girls would be 30 into 20 or 600, or the average weight here will be 1800 by 50, cancel, 36. This can be an average weight of the students in class. The other extreme would be there is only one girl in class. There is only one girl in class and her weight would be 30 and boys would be 49. Boys would be 49 and their sum of weights would be 40 into 49. 40 into 49 is 1960 plus 30. So 1990 divided by 50, which gives us the average weight 40 into 49, 1960. This is fine. This case it will be 39.8. In these two extreme cases, the average turns out to be 36 and 39.8. So my actual average has to lie somewhere within this range. The only option present within this range is option D, and that should be the answer. Next question. The average age of a class of 20 students is 15 years. The average age increases by 3 years if the age of the teacher is included. What is the age of the teacher? The equation-based way of doing this is 20 into 15 plus age of the teacher divided by 21 is equal to 18, or 300 plus T is equal to 378, and divided by n. So T, age of the teacher, will turn out to be 78. One way you can solve it is this. Another way you can solve it is simply see the teacher brings in the 15 average, and for 21 people, he brings in 3 extra. See, age of the teacher is 15 plus 21 into 3, or 15 plus 63. This is equal to 78. This is the deviation-based thinking. This is the equation-based thinking. Either of these ways are fine as long as you reach the answer 78. Next, the average weight of all the students in a class is equals the average of the average weight of the boys and that of the girls. Which of the following holds true? Now, this is the conceptual question. See, average weight of all the students in a class equals the average weight of the boys and that of the girls. This can happen. This can happen in one of two conditions. When, let's say, there are equal number of boys and girls. If the group sizes are identical, the average of the averages, if the group sizes are identical, the average of the averages is equal to the average of the two numbers itself. If, let's say, boys have an average of x and girls have an average of y, overall average will be x plus y by 2 if the number of members in both these groups is identical. This way we can do it, or the other way we can do it, or the other way it can work is if boys and girls have the exact same average. Both of them have the exact same average. Average is x and y. For boys, girls, total. If boys and girls have the same average, even then the total average would be x only. Even then the total average would be x only. So in one of these two cases, the average weight of all the students in class equals the average of the average weight of the boys and that of the girls. So the answer to the question is at least one of A or B. Either the number of people in both the groups, boys and girls, is identical, or the average weight of boys and average weight of girls are. One of these two situations has to be valid. Last question. Just before the last match in the season, the total number of runs scored by Sachin added up to 2100. In his last match, he scored 101 runs. As a result, his average for the season went up by 1. Find the total number of matches he played in that season if he got out in every match. Let's say his average prior to the last match was A and the number of matches he had played was N. So NA is equal to 2100. Now NA plus 101 divided by N plus 1, number of matches is increased by 1, leads to A plus 1. So NA is 2100. I can replace that directly. 2100 plus 101 is equal to NA plus A plus N plus 1, or A plus N is equal to 100. This NA and 2100 will cancel. This one will come over here, make it 100. Now I have two numbers that add up to 100 and multiply to give me 2100. You can use the quadratic equation idea or whatever you choose to do. You will reach, I will not directly give it. Say A is equal to 2100 by N. Place it here. 2100 by N plus N is equal to 100, or N square plus 100N plus 2100 is equal to 0. From here we get N minus 30 or N 70 is equal to 0. So N is equal to 30 or 70. Pay attention, when N is 30, A would be 70, or when N is 70, A would be 30. Finally, the question is find the total number of matches he played in that season if he got out in every match. See, prior to the last match, the number of matches he has played is 30 or 70. Plus 1. Total number of matches he has finally played at the end of the season is either 31 or 71, or the correct answer is option D. That concludes the entire video for averages. Hopefully you learned something. That will be all.